Hi, Honors Physics students. Today we're going to start our new unit on motion, and we're going to be following the notes that you received in class. There are also a copy of these notes online. So let's start talking about what it means to be moving. The first thing we're going to talk about is position. So if we want to talk about how an object is going to move, we have to talk about, first of all, where the object is in a position, and then we can talk about how its position changes. So when we talk about position is the location of any object at a particular point in time. When we talk about positions of an object, position is always relative to something else. You may be positioned in front of your computer, or I am positioned in my kitchen. So we have a certain spot that is in a reference frame. So I am in my kitchen, my reference frame would be in my kitchen. When we don't, in this class, we typically don't talk about reference frames. It's sort of a given that the reference frame is the earth or ground or something stationary relative to the ground. So that is a assumption that we will be making and carrying through this whole course. If our position is where we are, displacement is a very important term. It talks about how an object's position has changed. When you talk about displacement, it depends on the direction you're going. So you could move, a mile or a meter or a foot. But when we talk about how an object's displaced, it's very important to identify which way it's going. So did you go a mile east or a mile west or a mile north? If you're moving a meter, is it forwards or backwards or to the left or to the right? So when we talk about displacement is changing an object's position, and we have to identify some direction it's going in. Because we can identify direction or displacement as in a direction, we can associate any displacement with a positive and negative value. For example, you could say that if the left is a positive direction, if you go 5 meters to the left, you're going in a positive 5 direction. If left is positive and you move to the right, you'd be moving in a negative direction. So when we talk about displacements, because they have positive and negative values, we can use that reference frame and give them a positive and negative direction. The symbol for displacement is the lowercase d. We're going to use this in our notes. So if you look in your notes packet, we're going to be on the back page of your notes right now. And the very first thing that they talk about is displacement d. If we want to calculate what displacement is, you find out where your final position and your initial position are, and you just subtract the initial position from your final position, and that'll give you the expression for displacement. You won't find this equation in your reference tables. Displacement, just your final minus your initial, is something that is understood. The counter side to displacement is distance. When we talk about distance is the length of something traveled. It doesn't care about where you start or where you finish, just how much ground has been covered. So we say that distance is independent of direction. You can move around in a circle, and you'll cover a certain distance, but if you end up where you started, you would have a zero displacement, but you'd have some non-zero distance traveled. Because it doesn't depend on direction, we always consider distance positive. And if you want to know how much distance you've moved, you just have to take the sum of all your individual distances and add them up. So let's go through an example of this. In this example, we have a student that walks 5 meters to the right, stops, and then walks 3 meters to the left. If we want to find out what the displacement of the object is, we need to figure out how far it is from where it stopped. So if you're going 5 meters to the right and you turn back and walk 3 meters to the left, you end up 2 meters from where you started. So the answer to this would be 2 meters. But then because it's a displacement, we have to give it a direction, right? 5 meters to the right, 3 meters to the left, you still end up 2 meters from where you started, but you are to the right of where you started. And here we've given a displacement. We've given a value, 2 meters, that's called a magnitude. And we've given a direction, right? I want to note that whenever you talk about a physics term that has a direction associated with it, you could always give it without the direction if they ask you for magnitude. And we're going to see that in a minute. The next thing that they ask is what's the distance traveled by the student. So here we don't really care about where you start or where you finish, but how far you've actually gone totally over the ground. So if you walk 5 meters to the right and 3 meters to the left, you've covered a total of 8 meters. That is your distance. Meters. And then finally, the last thing I'm going to ask about is what is the magnitude of the student's displacement. The term magnitude refers to the value that doesn't have a direction associated with it. So if we have 5 meters to the right and 3 meters to the left, we have a displacement of 2 meters to the right. The magnitude of that displacement is just 2 meters. So we don't consider, when we talk about magnitude, we do not consider any of the directions. So the first and third question here are more or less the same question, but I would like to point out that when you talk about the magnitude of distance, that really doesn't matter because distance doesn't have a direction associated with it. On your next slide, you're going to see an example that goes through an example just like this. Go ahead and try that example, and then we'll pick this up after that.